Hi everyone. So today is decomposition. So remember, decomposition is basically just ripping things apart into simpler substances. And with that dance analogy, remember in synthesis we had the two single people hooking up and then slow dancing together. So a decomposition reaction is the exact opposite. So you'd have a couple slow dancing, music stops, and then they would separate and go their own ways. So that's basically what a decomposition reaction is. So the most difficult thing is obviously predicting what the products are. And again, I personally find it a lot easier to predict the products in a chemical formula than going through something like this, okay? So what we're gonna do here is sodium chloride is a binary compound. So basically what's gonna do is it's gonna split apart right there. Remember, sodium has a positive 1 valence and chlorine has a negative 1 valence. So that's where it's going to split. So it's going to produce sodium and then chlorine. Now remember, chlorine is one of the bloody 7, which I like to call it. So it would have a 2 there. So once that's there, then now I know that it's going to produce sodium and chlorine. Now be careful. You have to change the ending back to the element's name. You can't just put sodium plus chloride, okay? And then again, we'd want to balance this, so we'd put a 2 there and a 2 there as well. All right, so this is something that you probably would have taken in grade 10 science. This one here, same idea. What we're going to do is we're going to split this right here, and that's where I'm going to split it because those are my two things with valences. So it's going to split apart to give me aluminum, and it's going to give me oxygen. Now again, oxygen is one of the bloody 7. I can finish my word equation. It's aluminum plus oxygen. Again, we have to make it the regular element's name, not just put oxide there. And then the last thing we'd have to do is we would have to balance it. We got a 3-2 thing going here. So if I make that a 3, there's 6 oxygens there. 2 times 3 is 6 oxygens, 4 aluminum, and then that would have to be a 4. And then we have that whole thing balanced, okay? So those are a couple of examples of in the note where we have a binary compound and it decomposes to give us 2 elements. The last 2, these are the ones you want to put a star by. These are the ones that you generally will not get on a test, you will not get on an exam unless you pay particular attention to it. So what the note says is that if you decompose a carbonate, you will produce an oxide and carbon dioxide. So again, I like to go right here. I know I am going to produce an oxide. Now the oxide that I'm going to produce is with sodium. So sodium and oxygen are going to go together. Sodium has a +1 valence. Oxygen has a -2 valence. When I crisscross, I'm going to get Na2O, and it also produces carbon dioxide. And then we already know the formula for that. So in this case, it produces an oxide and carbon dioxide. So if you don't even know what oxide it is, you know you're going to get a mark for carbon dioxide here, and you should get a mark for putting down CO2 there. So this is a way of getting some part marks. Now, the oxide you're going to get is really whatever the metal is over here is going to continue over here. Remember, you can't destroy atoms. So if you have sodium atoms over here, you have to have them over here as well. So this would be sodium oxide. And then the last thing we have to do, of course, is we want to balance it. 2 sodiums, 1 carbon, 3 oxygens. 1 plus 2 is 3, so it's already balanced. So that's how you would do that one, okay? Here's a couple other examples. So here's another example of a carbonate. And remember, carbonates produce carbon dioxide and an oxide. Now the oxide is going to be attached to the calcium. Now, whenever you write formulas down, remember symbol, symbol, valence, valence, crisscross. So that would give me CaO, and then I'm also producing carbon dioxide. Name, I'm going to be calcium. I don't need Roman numerals or the Oschick system because there's only 1 valence there. So it's sodium oxide and carbon dioxide. And we want to balance it. 1 calcium, 1 calcium, 1 carbon, 3 oxygens. 1 plus 2 is 3 oxygens, so it would already be balanced. Hydrogen carbonates. This is, again, is one that if you don't pay particular attention to, you generally will get these wrong on a test and on the exam. So hydrogen carbonates, when they decompose, they are going to produce a carbonate, water, and carbon dioxide. So part of this is going to be easy because I already know it's going to produce water and carbon dioxide. So I'm getting part marks just by putting those things down. Now, I'm also going to produce a carbonate, okay? Now, this is going to decompose, and again, I know it's going to produce a carbonate, and the carbonate is going to be attached to sodium. So sodium has got a valence of +1, carbonate is -2. When I crisscross, I'm going to get Na2CO3. Water is easy, that's H2O, and then carbon dioxide. So again, even if you mess this one up, you still should get this mark and you should get that mark, so you're getting part marks along the way. All right? Now, I know it's going to be sodium carbonate. And incidentally, it doesn't matter the order that you put these in, as long as they are on the product side, it really doesn't matter, just like it doesn't matter what order these would be in. Now, we have to balance this. I have 2 sodiums there, so I'm going to need a 2 there. And if I do that, 2 hydrogens, I got 6, 3, 4, 5, 6. It's all balanced. So that was an easy one. And then this is the last one, aluminum hydrogen carbonate. Now again, I know it's going to produce a carbonate. It's going to produce water and carbon dioxide. Now, the carbonate it's going to make is with aluminum. So aluminum is going to go with carbonate. And notice what I did this. I just did symbol, symbol. Now I'm looking up its valences if you don't have them memorized. Aluminum is +3. Carbonate is -2. And then I crisscross. So the 2 goes there, the 3 goes there, which means I have to put my carbonate in brackets. I'm going to produce water, and I'm going to produce carbon dioxide. I can't stress this enough that when you are putting down a formula, you're not looking over here, you're taking care of that formula before you move on with anything else, okay? All right, so up top here, we're going to produce aluminum carbonate. We're going to produce water and carbon dioxide. And then the last thing we have to do is balance this. I got 2 aluminums here. So if I have 2 aluminum hydrogen carbonates, if I put a 3 there, I have 3 carbons, so I put a 3 there. 6, 9, and another 9 is 18. 9 times 2 is 18. So the oxygens are balanced and it's done. So that's basically, hopefully, some examples that get you to understand how to predict your products. So good luck with the questions. Take care.